Python Random Module. The random module in Python is a powerful tool for generating random numbers and performing various random operations. It offers a variety of functions that can be used in a wide range of applications, from simulations and games to data analysis and cryptography. Key functions and their uses. Random.randint, a, b. Generates a random integer between a and b, inclusive. Example, random.randint, 1, 10, generates a random number between 1 and 10. Random.randrange, start, stop, step. Generates a random number from the range start to stop, excluding stop. The step parameter specifies the step size between values. Example, random.randrange, 0, 10, 2, generates a random even number between 0 and 8. Random.random generates a random floating point number between 0.0 and 1.0, exclusive. Example, random.random generates a random decimal between 0 and 1. Random.uniform, a, b. Generates a random floating point number between a and b, inclusive. Example, random.uniform, 0, 1, generates a random decimal between 0 and 1. Random.choice, sequence. Returns a random element from a sequence, like a list, tuple, or string. Example, random.choice, apple, banana, orange, chooses a random fruit. Random.sample, population, k. Returns a list of k unique elements randomly selected from the population sequence. Example, random.sample, 1, 2, 3, 4, 5, 3, returns a list of 3 unique random numbers from 1 to 5. Random.shuffle, x. Shuffles the elements of the sequence x in place. Example, random.shuffle, 1, 2, 3, 4, 5, randomly rearranges the elements of the list. Additional considerations. Seed. The random.seed function can be used to set the seed for the random number generator. This allows for reproducible random sequences. Cryptographic security. For cryptographic purposes, the secrets module should be used instead of random, as it provides stronger guarantees for randomness. Example usage. Python. Import random. Hashtag generate a random integer between 1 and 100. Random_int equals random.randint, 1, 100. Print, random_int. Hashtag generate a random floating point number between 0 and 1. Random_float equals random.random. Print, random_float. Hashtag choose a random element from a list. Fruits equals apple, banana, orange. Random_fruit equals random.choice, fruits. Print, random_fruit. Hashtag shuffle a list of numbers. Numbers equals 1, 2, 3, 4, 5. Random.shuffle, numbers. Print, numbers. Applications. Simulations, modeling random events like coin flips, dice rolls, or card shuffling. Games, generating random numbers for game mechanics, such as enemy spawns or item drops. Data analysis, sampling data sets randomly for analysis or testing. Cryptography, generating random numbers for encryption and decryption keys. Python requests module. The requests module in Python is a simple yet powerful library used for making HTTP requests. It simplifies the process of sending HTTP/1.1 requests, such as GET, POST, PUT, DELETE, etc. Unlike Python's built-in erlib module, requests is much easier to work with for HTTP-related tasks. Here's a quick overview. Installation. To install requests, use pip. Pip install requests. Basic usage. Get request. Python. Copy code. Import requests. Response equals requests.get, https://api.example.com/data. Print, response.status_code, hashtag get the status code of the response. Print, response.json, hashtag get the response content as JSON, if applicable. Post request. Import requests. Payload equals key 1, value 1, key 2, value 2. Response equals requests.post, https://api.example.com/data, JSON equals payload. Print, response.status_code. Print, response.json. Handling parameters, headers, and auth. You can pass query parameters, headers, and authentication details easily. Get with query parameters. Params equals q, Python, sort, popular. Response equals requests.get, https://api.example.com/search, params equals params. Print, response.url, hashtag https://api.example.com/search q =Python &sort =popular. Adding headers. Headers equals authorization, bearer your _token_ here. Response equals requests.get, https://api.example.com/protected, headers equals headers. Handling authentication. From requests.auth import http basic auth. Response equals requests.get, https://api.example.com/auth, auth equals http basic auth, user, pass. Error handling. You can check if a request was successful by using the raise_for_status method. Try. Response equals requests.get, https://api.example.com/data. Response.raise_for_status. Accept requests.exceptions.http error as error. Print, if http error occurred, error. Python Statistics Module. The Python Statistics module provides functions for calculating various statistical measures on numerical data. It offers a convenient way to perform common statistical operations without relying on external libraries. Key functions and their uses. Statistics.mean, data. Calculates the arithmetic mean, average, of the data. Statistics.median, data. Calculates the median of the data, which is the middle value when the data is sorted. Statistics.mode, data. Calculates the mode of the data, which is the most frequently occurring value. Statistics.sdef, data, spar. Calculates the standard deviation of the data. If spar is provided, it's used as the sample mean. Statistics.variance, data, spar. Calculates the variance of the data. If spar is provided, it's used as the sample mean. Statistics.quantiles, data, n equals 4, method equals linear. Calculates quantiles, percentiles, of the data. The n parameter specifies the number of quantiles, and the method parameter determines the interpolation method. Statistics.harmonic_mean, data. Calculates the harmonic mean of the data. Statistics.geometric_mean, data. Calculates the geometric mean of the data. Example usage. Python. Import statistics. Data equals 1, 2, 3, 4, 5. Hashtag calculate the mean. Mean underscore value equals statistics dot mean, data. Print, mean underscore value. Hashtag calculate the median. Median underscore value equals statistics dot median, data. Print, median underscore value. Hashtag calculate the mode. Mode underscore value equals statistics dot mode, data. Print, mode underscore value. Hashtag calculate the standard deviation. Stef underscore value equals statistics dot stef, data. Print, standard deviation, stef underscore value. Hashtag calculate quantiles, percentiles. Quantiles equals statistics dot quantiles, data, n equals 4. Print, quantiles. Applications. Data analysis, analyzing the distribution, central tendency, and dispersion of data. Quality control, monitoring and evaluating product quality based on statistical measures. Financial analysis, calculating returns, risk, and other financial metrics. Scientific research, analyzing experimental data and drawing conclusions. Additional notes. The statistics module also provides functions for calculating summary statistics, such as the minimum, maximum, range, and sum of a data set. For more advanced statistical analysis, you might consider using libraries like NumPy, SciPy, or Pandas. Python Math Module. The Math module in Python provides access to mathematical functions defined by the C standard. It includes functions for basic algebra, trigonometry, logarithms, combinatorics, and other mathematical operations. Below is an overview of key functionalities. Basic usage. You don't need to install anything, the Math module is part of Python's standard library. Just import it and start using its functions. Python. Copy code. Import math. Key functions. Constants. Math.py, the mathematical constant pi, 3.14159. Math.e, the base of natural logarithms, e, 2.71828. Python. Copy code. Print, math.py, hashtag output, 3.141592653589793. Print, math.e, hashtag output, 2.718281828459045. Trigonometric functions. Math.sin, x sine of x is in radians. Math.cos, x cosine of x. Math.tan, x tangent of x. Math.assin, x, math.acos, x, math.addan, x inverse trigonometric functions. Math.degrees, x converts x radians to degrees. Math.radians, x converts x degrees to radians. Python. Copy code. Print, math.sin, math.py/2, hashtag output, 1.0. Print, math.degrees, math.py, hashtag output, 180.0. Logarithmic and exponential functions. Math.log, x, base logarithm of x to the specified base. If no base is provided, returns the natural logarithm. Math.log10, x logarithm base 10 of x. Math.exp, x returns e raised to the power of x. Math.pow, x, y returns x raised to the power of y, alternative to the operator. Python. Copy code. Print, math.log, 110, hashtag output, 2.0. Print, math.exp, 1, hashtag output, 2.718281828459045. Rounding and modulus functions. Math.ceil, x rounds x up to the nearest integer. Math.floor, x rounds x down to the nearest integer. Math.fabs, x returns the absolute value of x, float. Math.modf, x returns the fractional and integer parts of x. Python. Copy code. Print, math.ceil, 4.2, #output, 5. Print, math.floor, 4.7, #output, 4. Factorial and combinatorics. Math.factorial, x returns the factorial of x. Math.gcd, x, y returns the greatest common divisor of x and y. Math.com, n, k returns the number of ways to choose k items from n items, combinations. Math.perm, n, k returns the number of ways to arrange k items from n items, permutations. Python. Copy code. Print, math.factorial, 5, #output, 120. Print, math.gcd, 48, 64, #output, 16. Special functions. Math.sqrt, x returns the square root of x. Math.hypot, x, y returns the Euclidean norm, i.e., the square root of x superscript 2 plus y superscript 2. Math.isclose, a, b, rel underscore toll equals 1e9 returns true if a and b are close within relative tolerance. Python. Copy code. Print, math.sqrt, 16, #output, 4.0. Print, math.hypot, 3, 4, #output, 5.0, since 3 superscript 2 plus 4 superscript 2 equals 5 superscript 2. Useful for algorithms and data science. The math module is useful in algorithms involving numerical computations, such as geometry, combinatorics, probability, and more. Python Cmath module. The Python Cmath module provides functions for complex number arithmetic. It offers a convenient way to perform operations involving complex numbers, including addition, subtraction, multiplication, division, and finding the square root. Key functions and their uses. Cmath.sqrt, z, calculates the square root of the complex number z. Cmath.exp, z, calculates the exponential of the complex number z. Cmath.log, z, calculates the natural logarithm of the complex number z. Cmath.log10, z, calculates the base 10 logarithm of the complex number z. Cmath.phase, z, calculates the phase, argument, of the complex number z. Cmath.polar, z, converts the complex number z to polar coordinates, returning a tuple of the magnitude and phase. Cmath.rect, r, phi, converts polar coordinates, magnitude r, phase phi, to a complex number. Cmath.sin, z, calculates the sign of the complex number z. Cmath.cos, z, calculates the cosine of the complex number z. Cmath.tan, z, calculates the tangent of the complex number z. Example usage. Python. Import Cmath. #create a complex number. Z equals 3 plus 4j. #calculate the square root. sqrt underscore z equals cmath.sqrt, z. Print, square root, sqrt underscore z. #calculate the exponential. exp underscore z equals cmath.exp, z. Print, exponential, exp underscore z. Hashtag calculate the phase. Phase underscore z equals gmth dot phase, z. Print, phase underscore z. Hashtag convert to polar coordinates. R, phi equals gmth dot polar, z. Print, polar coordinates, r, phi. Applications. Signal processing, analyzing and manipulating signals represented as complex numbers. Control systems, designing and implementing control systems using complex numbers. Electrical engineering, analyzing circuits and systems involving complex impedances. Physics, solving equations involving complex numbers, such as those in quantum mechanics and electromagnetism. Additional notes. The CMIT module also provides functions for calculating the conjugate, real part, and imaginary part of a complex number. For more advanced mathematical operations involving complex numbers, you might consider using libraries like NumberPy or SciPy.
मैरिज के बाद वो अच्छा और हाँ वो भी मैं कम से कम मेरे तरफ से 1 लाख रुपए तो रख लेना मैं
हाँ, बिल्कुल।